Over thousands of years, human beings have created remarkable civilizations. Once only able to draw on rocks, we have now landed on the moon. We have gone from learning to use fire to capturing quanta. From firing ceramics to making spacecraft that can fly to the edge of the solar system, human beings have never stopped in their exploration of time and space. Where are we headed? When will we get there? These questions come from our most basic instincts. Because of this instinct, BeiDou and other navigation satellite systems in the world play a special role in creating a civilization of time and space.
如果可以穿越到远古，我们会发现，那时的人类只能生活在出生的那小片地方。面对远方，他们常常感叹遥不可及。那时的人们甚至认为地球是走不到尽头的平面。但是，敢于跋涉的智者慢慢发现，可以通过观测日月星辰、山川河流、树木，或者是堆砌起石块作为标记，来判断自己的位置和确定时间。这便是最原始的导航。早期地图的功能就是导航。我们的祖先已经登上峰顶，甚至像天空中的鸟儿一样俯瞰大地了。运用于导航的智慧，人类的活动空间逐渐扩大，从陆地延伸到海洋，从地面飞向太空，这便是文明的进步。
This is a model of an ancient ship from the Tang dynasty, complete with 9 watertight compartments. Of all the ancient ships in the world ever discovered, this was the earliest ship to have these compartments. As early as the 7th century, these ships sailed in inland rivers in southern China and its surrounding seas. Navigation is derived from the Latin word for sea. Being able to navigate the vast sea is a matter of life and death. People in ancient times could find their way around the sea by using the stars in the sky to guide them. In Western astronomy, this is the tale of the Great Bear, and these 7 bright stars are usually referred to as the Big Dipper. In Chinese it is called BeiDou, or North Dipper, because it sits in the northern sky. By extending the distance between the stars of Merak and Dubhe, we can locate Polaris, the North Star. For hundreds of years, Polaris happened to be located in the direction of the Earth's axis of rotation, so if observed from the northern hemisphere, its change in location is minimal. Due to the rotation of the Earth, BeiDou appears to be revolving anti-clockwise around Polaris. The ancients would identify time and direction according to the Dipper arm, based on BeiDou's relative location to Polaris. As an important benchmark for time and space in ancient times, BeiDou started to be worshipped by humans and gradually became a totem of civilization. In 2020, the Palace Museum celebrated its 600th anniversary. When designing the palace, Zhu Di, Emperor Changzu of the Ming Dynasty, ordered that the worship of BeiDou be integrated into its layout. By decorating the roofs with treasure bottles, he incorporated the 7 stars in the palace complex. By integrating myth, science, and art, craftsmen turned a celestial palace of aesthetic fantasy into a reality in the human world. The Chung Grey Pavilion in the northwest of the Imperial Garden became a special space in the Qing dynasty for worshipping the BeiDou gods, in the hope they would bring peace in the human world. Zhu Di believed that BeiDou would lead his fleet across the world. From 1405, a huge fleet, led by Zheng He, sailed to the Western Pacific and the Indian Ocean 7 times, visiting over 30 countries and regions, as far as Eastern Africa and the Red Sea. They were the largest-scale maritime expeditions in the world at the time. At the China Maritime Museum, a star tethering board illustrates an ancient navigation method used by Zheng He's fleet. There is a written record on Zheng He's compass map that states, "The ship is 4 Zhe to the North Star." Zhe could be translated as digit, which refers to the angular unit of measure for altitudes. Each board corresponds to a fixed number of digits. In navigation history, the ancient Chinese discovered very early the trick of gauging direction by observing the Earth's physical phenomena. After the compass was introduced into Europe at the end of the 12th century, navigation was freed from the limits of seasons. This also sped up the arrival of the Age of Discovery. In the summer of 1492, Christopher Columbus set sail from Palos de la Frontera in search of the Orient. However, due to undeveloped navigation technology and maps, he accidentally discovered the American continent instead. After the 16th century, Europeans saw navigation as a main task in their bid to gain great interests overseas. This push prompted the great Italian astronomer Galileo Galilei to invent the astronomical telescope, transform the compass, and explore celestial navigation. He spent his whole life looking for increasingly accurate methods of navigation. Xu Guangqi, a Chinese scientist who was a contemporary of Galileo, was the first person to introduce the concept of the Earth's sphere into China. Before then, maps in most Chinese people's minds were a complicated mix of memory, imagination, and culture. Today, tens of thousands of precious ancient literary works are preserved in the National Library of China. The national map during the Qianlong reign was completed based on the complete national map during the Kangxi reign, compiled in 1718. It became the first edition of the official national map of China and was also one of the earliest maps divided according to parallels. Mountains and rivers were measured accurately by latitude and longitude for the first time. When European scientist Joseph Needham saw this map, he said that it is better than all European maps at the time. During the Age of Discovery, people made constant progress in their understanding of the latitude and longitude of the Earth, laying the foundation for the standardization of navigation.
经线和纬线的出现，让世界从各自绘制地图的时代，带向全球统一的位置标准化时代。我们的先人仰望北斗七星，发现它有规律性指向，终年悬于北半球夜空，能为人指引方向。经纬和北斗，让我想起唐代大学者孔颖达这样解释文明：经天纬地，曰文；照临四方，曰明。在天地间，能发现空间与时间的标准，我们的时代就向前迈进了一大步。
In 1735, the British clockmaker John Harrison invented the marine chronometer. The device calculated longitude while sailing by determining distance through time calculation. The invention of the marine chronometer combined time calculation, distance measurement, and mapping. Chronometer navigation progressed constantly from the beginning of the 18th century to the 19th century. Modern navigation was beginning to take shape. World War II was a huge calamity for all humanity. In September 1944, a German rocket flew across the English Channel and struck London. Nazi Germany had pinned its hope on this secret weapon as a deterrent on the European battlefield. Named the V2 rocket, it was the first ballistic missile used in warfare. In fact, Nazi Germany had begun developing supersonic missiles in 1932. German rocketeer Werner von Braun was the chief designer. His research didn't help the Nazis win the war, but it did make him a pioneer. In April 1945, Germany's armies began retreating in Europe, and America and the Soviet Union started to seize the Germans' high-tech achievements. This rare clip was filmed by the Americans when they launched the V2 rocket into outer space. The rocket allowed human beings to see real space for the first time. During the 1940s and 50s, rapid progress in rocket and missile science heralded the imminent arrival of enlightenment in aerospace studies. On October 4th, 1957, the Soviet Union launched the first artificial Earth satellite into space. It was named Sputnik 1, which means companion in Russian. In the Cold War era, the US was made anxious by the fact that the Soviets had been the first to achieve this. As the Americans were monitoring the satellite, they found that when it got closer to the ground receiver, the signal frequency it received would gradually increase and would drop as it flew further away. This phenomenon is known as the Doppler effect. American researchers realized that based on the same principle, but in reverse, they could determine the location of the signal receiver if the satellite's location was known. This accidental discovery later became the theoretical basis of satellite positioning. Two years after the launch of Sputnik 1, the US Navy began its navigation satellite research scheme, named the Navy Navigation Satellite System, or NNSS. It marked the beginning of the age of satellite navigation. NNSS was put into use in 1964 and retired in 1996 when it was completely replaced by GPS. Within half a century of GPS being developed, Russia's GLONASS, China's BDS, and the European Union's Galileo together made up a huge navigation satellite network above the Earth. It was a world-changing network. Ever since the Chinese invented the compass, navigation has progressed continuously from sailing to space travel. Humans have finally made the leap from relying on the stars to mastering their knowledge of space. The logo of the UN International Committee on Global Navigation Satellite Systems features 4 flying navigation satellites, one of which is China's BDS. In November 2018, the 13th meeting of the International Committee on Global Navigation Satellite Systems was held in Xi'an. In his message of congratulations to the meeting, Chinese President Xi Jinping wrote, "China will share the achievements in BDS's construction and development with the rest of the world for the joint promotion of the development of global satellite navigation."
中国愿意同世界各国分享北斗成果，中国人始终这样努力着。半个多世纪的导航卫星发展史上，虽然各国都是独立的开发建设，技术途径也不一样，但是人类真正的科学真理和精神，最终会让我们彼此了解，握手合作。看看今天的世界，全球化是人类发展进步的大趋势。我们比以往任何时候都更需要信任、尊重和理解。构建人类命运共同体是一个美好的目标。或许，导航卫星领域的发展会给今天这个世界 一些导航之外的启迪。
In the past 10 years, BDS has become compatible and interoperable with the navigation satellite systems of the US, Russia, and Europe. China built the BDS based on its own power and opened the system to the whole world when it was completed. BDS is being used more and more in international organizations for civil aviation, maritime affairs, search and rescue satellites, and mobile communication. Several international standards that support the BDS have also been issued. In 2020, BDS served more than 100 million users in countries and regions along the One Belt, One Road route. Products related to BDS have been exported to over 120 countries and regions. BDS-based services such as land mapping, precision farming, digital constructing, and intelligent ports have been successfully applied in the ASEAN region, South Asia, Eastern Europe, West Asia, and Africa.
如今，导航卫星已布满地球上空，但这绝不是人类导航的终点。北斗的故事还将继续。
In contemporary life, the indoors, underground, underwater, and interstellar space are areas that still cannot be covered by existing navigation satellites. The world is vast and the other shore is distant, but we will finally get there. By 2035, BDS will become a more intelligent, ubiquitous, and integrated comprehensive national positioning, navigation, and timing system. This is the BeiDou that belongs to us, a legend filled with the bravery, struggles, and creativity of the Chinese people. No matter how long it takes, the BeiDou navigation satellite will continue to soar, creating an even better future for human beings.